So, welcome to Power System Engineering Laboratory. Today we will start our experiment for performance of what your experiment is? Performance of induction generator. So today we will see how one induction generator is started and how to take the readings. How to take the readings by converting that one to a model. So generally what happens, this is our instruction manual of the lab, power system lab, and here we will do this one. This is the circuit diagram made for induction generator. Okay, induction generator. So what we will do here today? So bit by bit we will go. You see, this one is an induction motor. This is one induction motor which is of slip ring type. Slip ring type. So we have to start this one as a slip ring type induction motor. At that time, this one, as it is written as DC motor, so if this one is acting as an induction motor, so it will act as a prime mover of this DC generator. It will act as a generator first. Okay? So this will act as a DC generator. So now our aim is to make this one as induction generator. So how it is possible? It is acting as a three-phase induction motor, slip ring type, and we have to make this one as induction generator. So at that time, we have to make this one as a prime mover. We should act as a prime mover, but it is very difficult. We are giving 3 supply to this one. This is acting as a slip ring type induction motor. At that time, this is acting as a DC generator. Again, I am repeating again. So we have to make this one as motor, so that this will act as a generator. Okay. So what is the technique behind that? 3 phase will be supplied to this one. Very brief, I am telling about that. If you have any question, you can raise that. Okay. So 3 phase is to be connected here. These are the meters connected for current and watt measurement. And at that time, this will act as a motor. Sorry, generator. So we can get the terminal voltage of the generator. But what we have to do, to act as a prime mover, we have to heat DC supply to make it a motor. Very peculiar. It is a technical challenge. How to do that? This is acting as a generator. We have to make it as a motor. Is it possible? We have to make that one as possible. So how to do that? Some external DC source should be available here, and the output of this generator, we have to connect to the external source of the DC. Is it possible? So what are the conditions? You have to make that one as possible. As per our theory concept, what should be there? In your AC circuit, you have already done your synchronization with infinite bus bar. So for that purpose, what are the conditions for AC? Your voltage should match with your bus bar, frequency should match, and phase sequence in case of AC. But in case of DC, what we have to do? Your voltage of the external source, which is a constant, it is coming from the rectifier or rectified output or any DC generator. This source is available like this. So this is fixed. This one is variable. Because we are doing the experiment, you can control that voltage. So with reference to your voltage of the external source, you have to match the voltage of the generator. And the second parameter is what? First, voltage should be matched, and frequency. How to get frequency in case of DC? Is it available? Frequency. So polarity should be same, no frequency. So voltage and polarity. Polarity should match, means plus to plus, minus to minus. And the first condition is voltage should match. So polarity should be same and voltage should match. So what to do? you have to start this one as induction motor, and with reference to this voltage you have to make these two, voltage and polarity. After that you have to connect with the external source. If it is not matching and you have connected, then a severe fault will occur. Okay, so after doing that, what you have to do, your aim is to make this one as induction generator. First it is acting as motor. Again another technical challenge. If you are connected with external source, you have to drive this one as a motor. Now it is possible. If it is driven, then what will happen? Your main aim is to get it induction generator. Repeatedly I am telling you. But here it is acting as a motor means what? Your NS and NR. You recall that your NS and NR should be less than in case of motor in comparison to your NS, synchronous speed and rotor speed. Clear? But if NR is greater than NS, then at that time it will act as a generator. If you fulfill that condition, then it will definitely act as an induction generator. So what you have to do? You have to drive this one to increase your NR speed. NS starter regala, NR rotor. Okay. If NR is gradually increased, how is it possible? It is possible in this prime mover only, which is acting as a motor. If NR is gradually increased, then what will happen? It will act as a generator. At that time, instead of it is consuming power from the grid, it will deliver power to the grid. First, in case of motor, 3-phase motor, this wattmeter will show the power consumed by this device as a motor. But our aim is to get the characteristic of induction generator. When the NR is increased from NS, that means that relates to your sleep. The difference is not let us be very well. NS and NR. Rotating magnetic field, it is rotating like that. So if the sleep NR is increased, then it will come to induction generator. Let us start our experimentation to verify this, whether it is possible or not. For that purpose, what you have to do? You see, this is the motor part, these are the connections. L1, L2, L3, supply terminals. Emitter is connected. And wattmeter. This one is wattmeter. Okay. The L1 and L2 is the main supply. Is to be connected to the starter of the motor. And the rotor, as it is a simpering type, this motor should be an external resistance. 3 external resistance in a balanced way should be in star form. Should be in star form like this. Okay. Now we have to start the motor side. This one, and the generator connections are available here. This A1, A2, SH1, SH2, very simple. This is just like on the DC, not series motor. You are connecting some parallel. Okay. So these are the terminals A1, A2, SH1, SH2, and this L1 and L2. This L1 and L2 are the external DC source available, which is available here. So these are the reference point of external source, and these two are the generating output. So if you will start in this way, this is open, and we have to make this one start. Wattmeter connection is alright, it is alright, and the external resistance of the rotor should be in maximum position during the period of starting. These are the background. These are the ground should be clarified related to your machines. But we are not doing any part for the machines. We are doing for the power system. That means after generation of the induction generator, that is our study purpose for power system. Okay. We have to measure the power how it is consuming power, how it is delivering power to the system. Okay. So let us start. Let us induction part. So this resistance should be in 100% as it is already discussed. So this is in 100% position, this one, and make it start. Motor is started, it is rotating. Okay. So what you have to do? You have to make that one in induction. Three-phase induction. Not generator, motor. Motor. So for that purpose, you gradually in a balanced way, you gradually increase the resistances. You come forward one by one. Don't keep it short circuited, otherwise the heavy fault will be ready. Okay. Gradually increase it this way, one by one.
हाँ धीरे धीरे धीरे
No, very slow.
लोग नहीं भूत
हाँ, balance.
Careful, careful.
Now the motor is running. We can get the output of the DC generator. We will measure that one as we have already discussed. Now